Imagine a future where machines don't just serve us, they anticipate us. Where humanoid robots walk among us with expressions, instincts, and the ability to learn faster than we can teach. A world where artificial intelligence doesn't just react, but decides. That future? It's no longer a concept. It's arriving faster than anyone expected. Welcome back, guys. Alfie here with all the latest AI robot developments of the week. We're diving into this week's biggest AI and robotics breakthroughs, and I'm telling you now, we are not ready for what's coming. From robots showing human-level skills to AI systems pushing the boundaries of what was once considered impossible. These updates will blow your mind. You're watching the AI Nexus, and this is your weekly reality check on the fast-approaching future. Let's jump in, because the machines are moving and the world will never be the same. Robot era has just taken a massive leap forward in humanoid robotics with the unveiling of its full-size bipedal robot, the L7. Standing 171 centimeters tall and weighing 65 kilograms, the L7 isn't just built for show, it's engineered for versatility. In a jaw-dropping debut, the robot wowed audiences by performing complex breakdancing moves, including a flawless 360-degree spin jump, something no other humanoid robot has achieved publicly before. But the L7 isn't only about flashy tricks. It's surprisingly well-rounded, capable of both delicate and demanding tasks. From folding clothes with precision to efficiently sorting objects in an industrial setting, this robot moves seamlessly between entertainment and real-world utility. Even more impressive? It can run at 4 meters per second, faster than the average human jog. At the heart of this breakthrough is ERA-42, Robot Era's proprietary single end-to-end embodied large model that powers all of L7's intelligent behavior. With 55 degrees of freedom, L7 demonstrates remarkable dexterity, balance, and adaptability. It's not just reacting to commands, it's learning, adapting, and performing in real time across vastly different environments. Developed by a top-tier team of engineers and AI researchers from Tsinghua University's X Lab, L7 represents a new benchmark for what full-size humanoid robots can do. Whether it's lighting up a stage or streamlining a production line, L7 is redefining the future of physical AI, one spin jump and factory shift at a time. Tesla's Optimus humanoid robot just made a surprise appearance, serving popcorn at the soft opening of Tesla's first retro-style diner. And while this moment might look lighthearted on the surface, it quietly signals a big shift in how humanoid robots are entering real-world environments. Optimus handing out snacks might seem like a small step, but it showcases why humanoid form factors are so powerful. There's no need to redesign the popcorn stand, retrofit the kitchen, or build a custom robotic arm for one task. Instead, you simply introduce a robot shaped like a human, ready to step into a role built for one. Even beyond the snack-serving cameo, the potential is much bigger. A humanoid like Optimus could do more than just serve food. It could maintain the popcorn machine, refill supplies, or clean up spills on the floor. That's the beauty of general-purpose robots. The same unit can adapt across tasks without swapping hardware or retooling environments. The robot was likely teleoperated during this demonstration, but that doesn't diminish its impact. It's a smart, strategic use case that shows Tesla is inching closer to real-world deployments. A controlled setting like a diner makes the perfect training ground, structured enough to keep things safe, but busy enough to simulate human interaction and daily tasks. This popcorn moment might seem simple, but it's a preview of a future where humanoid robots quietly blend into our everyday lives, one snack at a time. In a recent video, Unitree's G1 Humanoid lost control again, an unsettling but important reminder of the growing pains in humanoid robotics. Whether it was a software glitch, hardware hiccup, or human error, the incident highlights a reality we can't ignore. Humanoid robots, like all complex systems, are prone to failure. There are endless ways things can go wrong. Broken actuators, buggy code, unexpected edge cases, or even cyber attacks. That doesn't mean humanoids shouldn't be developed or deployed. It just means we're in the early days, much like the early 1900s for automobiles. Back then, the US saw 20 deaths per 100 million miles driven. Today, it's under 1.5, Still not zero, still not perfect, but dramatically improved through regulation, technology, and real-world experience. We can't expect robots to be 100% safe, not now, and maybe not ever. The real question is, how safe is safe enough? We don't yet have the data to answer that confidently because humanoid robots haven't spent enough time working in the real world among people. But they need to. From assisting the elderly to handling dangerous industrial tasks, their potential is enormous. Getting there means accepting some risk and building systems that continuously improve through iteration and feedback, just like cars did. That's the tightrope we're walking. Over-regulate and we stall innovation. Move too fast and we risk harm. The recent Unitree G1 mishap is a wake-up call, but it's also part of the process. Progress doesn't come without setbacks. Unitree's G1 humanoid robot just took a big step forward in real-world dexterity, and it's surprisingly gentle. In a recent demo, G1 was seen handling fruit with fine-grained precision, carefully distinguishing between individual pieces and placing each one delicately into a basket. It even demonstrated the ability to gently wipe an apple before setting it down, a task that requires not just robotic strength, but a deep level of control, contact sensitivity, and fluid motion. This kind of manipulation is incredibly difficult for robots. Fruit is fragile, irregular, and unpredictable. Wiping an apple may seem simple to us, but it blends multiple complex elements. But the surprises didn't end there. In another video, G1 was spotted washing a car out in the wild. That's right, not in a lab, not in a simulation, but out in the open, performing a task that combines large-scale motion, multi-surface interaction, and a ton of environmental variables. Wind, water, terrain, none of it scripted. These demos hint at something bigger. Unitree is not just focused on movement or flashy tricks. They're training their robot to take on useful everyday tasks, both delicate and dynamic. A Headform tech has just unveiled a new humanoid demo that brings human-robot interaction one step closer to feeling natural. The latest update features real-time gaze tracking and facial recognition, allowing the robot to detect human presence and respond with subtle, lifelike eye movements. This may sound simple, but it's a big leap in social robotics. Eye contact plays a critical role in how humans communicate, and replicating that in machines is incredibly complex. A Headform's humanoid doesn't just stare blankly, it tracks your face, adjusts its gaze in real time, and makes eye movements that feel intentional and reactive. The result is a robot that feels more present, more aware, and more engaging. It's not just waiting for commands, it's watching, reacting, and acknowledging you in ways that mirror human behavior. Unitree Robotics just dropped an impressive demo of its Delight robot arm, and it's exactly what the name suggests. In the video, the arm showcases precise coordination and incredibly smooth motion, moving with a level of grace and control that feels almost human. The demo highlights the robot's ability to perform fluid, synchronized tasks with high repeatability, an essential requirement for both industrial applications and home robotics. Whether it's stirring, flipping, or transferring objects between positions, the Delight arm handles it all with elegance. One clip in particular sparked attention, the robot smoothly mimicking the motions of stir-frying. While it's not tossing noodles just yet, the accuracy and finesse in its movements suggest we're not far from hands-free cooking becoming a reality. In a recent video posted on X by Reborn AGI captioned "Robotic Dogs versus Real Dogs," a fascinating moment unfolds as a real dog comes face-to-face with its robotic counterpart. The short clip captures the curiosity, confusion, and subtle tension that arises when two very different kinds of creatures meet. One organic, one mechanical. The real dog approaches cautiously, sniffing and observing the robot's movements with clear interest, but also a touch of wariness. The robotic dog, likely programmed for basic locomotion and reactive behaviors, continues walking in a lifelike manner, its mechanical legs imitating the gait of a real canine. It's a brief but powerful moment that highlights how close robotics is coming to mimicking natural movement, and also how animals instinctively recognize the difference. While lighthearted on the surface, the video raises deeper questions about perception, embodiment, and acceptance, both human and animal, of robots in our everyday lives. If a dog can be this intrigued by a robot, How will humans react as these machines become more common in homes, parks, and public spaces? ByteDance's Seed team has just unveiled Seed GR3, their latest Vision Language Action (VLA) model, and it's a major leap forward in embodied AI. GR3 is designed to tightly integrate visual perception, language understanding, and robotic control, allowing robots to comprehend abstract commands and act on them across diverse environments with minimal guidance. What makes GR3 stand out is its ability to generalize, something most VLA models struggle with. It can recognize and adapt to unfamiliar objects and environments without needing exhaustive training data. In fact, it requires only minimal human supervision to fine-tune, making it significantly faster and more cost-effective to deploy in real-world applications. Whether it's understanding a vague instruction like "clean up the area" or identifying an object it hasn't seen before, GR3 handles it with surprising fluidity. This level of abstraction is critical for building robots that can truly assist in dynamic human environments where not everything is pre-labeled or predictable. GR3 also introduces architectural improvements that boost its performance on long-range, multi-step tasks and high-dexterity operations. That means it's not just smart, it's physically capable too. From warehouse automation to household assistance, GR3 opens the door to robots that are more versatile, intuitive, and responsive. ByteDance's push into embodied AI with GR3 signals more than just a research milestone. It reflects a future where intelligent, adaptive robots could be trained quickly, affordably, and rolled out widely, transforming how we think about human-robot collaboration. Remember that jaw-dropping card-dealing demo at ICRA that showcased a robotic hand with near-human dexterity? At the time, it was teleoperated, an impressive feat, but still reliant on human control. Now X-Square Robot has taken it to the next level. They've unveiled an end-to-end large model that enables fully autonomous manipulation, and yes, the robot dealer is officially open for business. This breakthrough model isn't just mimicking human motion. It's interpreting the scene, planning its actions, and executing them with precision, completely on its own. From picking up a card to flipping, sorting, and dealing it with finesse, this system blends vision, reasoning, and motor control in real time. Achieving this level of autonomy in fine motor tasks is notoriously difficult. It demands seamless coordination between perception, planning, and physical execution. Spirit AI has just raised nearly 600 million RMB in a significant pre-A+ funding round, led by e-commerce giant JD.com. Major institutional investors, including the China Internet Investment Fund and Zhejiang Sci-Tech Venture Capital Fund, also participated, signaling strong confidence in Spirit AI's ambitious roadmap in the humanoid robotics space. The company attributes its momentum to a strategic blend of tech barrier plus commercialization plus Team Gene, a model that prioritizes solving real-world problems while leveraging cutting-edge innovation and a deeply experienced team. This approach ensures that their product development is not only forward-looking, but also grounded in immediate market needs. This funding round closely follows the June launch of their new humanoid robot, MOZ-1. Designed for high-performance tasks, MOZ-1 features 26 degrees of freedom, high-power density integrated force control joints, and offers zero-latency teleoperation. It's not just a showcase of mechanics, it's a serious step toward functional real-world robotics. MOZ-1 is powered by Spirit V1, the company's proprietary Vision Language Action (VLA) model. This AI brain enables the robot to perform complex, nuanced tasks like tidying up a cluttered desk by integrating perception, understanding, and physical action in real time. What sets Spirit AI apart is its deep synergy between software and hardware. With fresh funding and a clear technical edge, the company is quickly emerging as a serious contender in the race to bring useful, intelligent humanoids into everyday life. UniXai Robotics is charging full speed ahead, and the robot fight scene is about to get even more intense. Hot on the heels of Unitree's buzzworthy updates, UniXai has officially announced a robot combat competition set to launch this December. A full-scale robot WWE league. Think high-intensity humanoid showdowns powered by cutting-edge AI and custom-built mechanics. Backing this momentum is a massive funding milestone. UniXai just secured nearly 1 billion RMB in 2 powerful investment rounds. The pre-A++ round was led by Xpeng's Starship Capital, while the A1 round brought in major names like JD.com, KTL Capital, and Huakong Fund. With this financial fuel, the company is accelerating everything, from production lines to market-ready upgrades. Their roadmap includes 3 new humanoid robots and a fresh quadruped model. UniXai is scaling up manufacturing and pushing for upgraded systems by Q4 2025, aiming for reliable delivery and serious industry presence. But it's not just about quantity, it's about next-level tech. Their motion control team has engineered custom joints and applied advanced Sim2Real techniques. The result? Humanoids capable of fluid, high dynamic movement and precise control, even under fight conditions. The upcoming December competition is more than entertainment. It's a public showcase of how far robotics has come. UniXai is clearly betting big on embodied AI, and now all eyes are on their fighters to see if they can deliver blows as smart as they are powerful. Magic Lab is wasting no time. Just weeks after their last major release, they've unveiled the Magic Dog W, a powerful new addition to their robotics lineup. This wheeled quadruped robot is already being called a performance leader in its category, combining the stability of 4 legs with the speed and flexibility of wheels. The Magic Dog W is purpose-built for agile mobility and all-domain traversal. Whether it's navigating urban environments, industrial spaces, or rugged outdoor terrain, this robot is designed to handle it all with ease. The wheeled leg hybrid approach gives it the edge in both maneuverability and efficiency, allowing for fast, smooth movement across challenging surfaces. While specific technical specs are still limited, Magic Lab is clearly positioning the Magic Dog W as a high-performance platform, potentially useful in logistics, exploration, surveillance, or even rescue operations. Given the company's recent pace of innovation, this release signals their growing ambition to compete not just in humanoid robotics, but also in high-mobility quadrupeds. With back-to-back breakthroughs, Magic Lab is quickly becoming a name to watch in the robotics race. The Magic Dog W isn't just a new robot. It's a bold step toward redefining what mobile robotics can do. Dobot's latest innovation is turning heads in the robotics world. A Hexopod Bionic robot that's proving its strength in real-world conditions. In recent outdoor testing, this 6-legged robot demonstrated remarkable movement performance, powered by reinforcement learning. Unlike traditional wheeled or bipedal robots, Hexapods offer a unique advantage: inherent stability. And Dobot's model takes full advantage of that. From uneven ground to steep inclines, the robot handled diverse and challenging terrains with impressive agility and balance. It adapts on the fly, learning from its environment to optimize each step in real time. The use of reinforcement learning means the robot doesn't just follow pre-programmed paths. It actively improves its performance through trial and error, just like an animal learning to walk more efficiently. This approach allows for a far more flexible and robust locomotion system, especially useful for outdoor exploration or missions in unpredictable environments. Dobot's Bionic Hexopod is a clear example of how biologically inspired designs, combined with modern AI, can push the boundaries of robotic mobility. As more testing unfolds, this could become a go-to platform for tasks that demand both resilience and adaptability. Dex Force has just unveiled its second-generation humanoid robot, the Dex Force G1 Pro, and it's already turning heads in the robotics community. This upgraded model builds significantly on the foundation of the original W1, aiming to push humanoid performance, precision, and control to a whole new level. The W1 Pro isn't just a cosmetic upgrade, it's a leap forward in technical capability. Dex Force has focused heavily on improving motion control, joint strength, and dynamic balance. Early demos show off smooth, coordinated full-body movements that look far more natural and fluid than typical rigid robotic motion. Whether it's walking, turning, or manipulating objects, the W1 Pro delivers impressive agility and responsiveness. What truly sets this generation apart is its refined hardware-software integration. Dex Force has enhanced the robot's real-time feedback loops and AI-driven perception, enabling it to react quickly to environmental changes and interact more effectively in complex scenarios. Combined with robust mechanical design, the W1 Pro appears capable of operating reliably even under demanding conditions. This release also aligns with a broader industry push toward practical humanoid deployment. UniXai is stepping into the spotlight with a major dual release: a self-developed lightweight, high-torque joint module and an 8-axis bionic robotic arm. These aren't just new components. They're the foundation for a more open, accessible future in embodied AI. The joint module stands out with its all-in-one integration of drive, perception, and control, enabling precise, stable, and flexible performance. Designed for high torque while remaining lightweight, it's a versatile building block for a wide range of robotic systems, from arms to humanoids. Paired with this is UniXai's uniquely designed 8-axis robotic arm. Departing from traditional industrial designs, this arm emphasizes bionic structure and adaptability. Its extra degree of freedom allows for more natural, complex movements, ideal for delicate tasks in fields like healthcare, manufacturing, or service robotics. Unitree Robotics is making major moves, both in the financial world and the fight arena. The company has officially completed its IPO preliminary registration, a critical milestone on its journey to the public markets. According to the filing, Unitree's IPO could be evaluated for listing eligibility as early as October 2025. This positions the company as one of the first major humanoid robotics players to potentially go public in the near term. The filing also reveals that Wang Xingxing, Unitree's founder and de facto controller, holds 34.76% of the company's equity, underscoring his strong influence over its strategic direction. With its growing product line, mass production capabilities, and international attention, this IPO could open doors for expanded R&D and global market reach. Meanwhile, Unitree is continuing to build hype through the world of humanoid mech fighting. Following the buzz of the CMG World Robot Competition Mecha Fighting Series, another thrilling event has wrapped up: the Kunlun Fight Humanoid Mech Fighting Competition. In a gripping final match, the red team took home the golden belt. What made this event even more unique? Professional boxers were remotely controlling Unitree G1 humanoid robots, combining real combat instincts with robotic strength. This blend of sports and robotics not only showcases the capabilities of Unitree's hardware, but also fuels public excitement around the future of robotic competition and entertainment. From the stock exchange to the battle ring, Unitree is clearly positioning itself as a major force in both business and robotics innovation. Uptek has just unveiled its most advanced industrial humanoid robot yet, the Walker S2, and it's packed with features that make it one of the smartest, fastest, and most capable humanoids in the game right now. Let's start with its brain. The Walker S2 is powered by Group Brain Network 2.0 and co-agent technology, giving it the ability to learn autonomously and collaborate in real time with other machines. This means it's not just following orders, it's evolving alongside its environment and robotic peers, making it smarter and more adaptable over time. On the performance side, the numbers speak for themselves. Walker S2 can walk at 2 meters per second, twist its waist a full plus 162 degrees, and operate within a 0 to 1.8 meter workspace. The robot is also equipped with 4th-generation dexterous hands that can perform tasks with sub-millimeter precision, enabling it to handle intricate operations with impressive finesse. But here's the real game changer. Walker S2 features the world's first 3-minute autonomous battery swap system. This means the robot can operate around the clock. No downtime, no recharging breaks. It's designed for continuous deployment in industrial environments, making it a serious 24/7 workhorse. With Walker S2, Uptek is signaling a major leap forward in real-world humanoid deployment. It's not just a robot, it's a platform built for the future of intelligent labor. That wraps up this week's AI Robot Update. And honestly, every week feels more like science fiction turning into reality. With robots evolving faster than ever, the line between human and machine is starting to blur. We'll be tracking every mind-blowing moment, so make sure you're following along. Trust me, you do not want to miss what's coming next. Thanks for watching, and we'll catch you in the next one.